Welcome to Summarize Science. Have you ever wished you could replay a moment in slow motion? What if we could do that for events that happen a million billion times faster than the blink of an eye? For years, scientists have tried to create time-reversed light waves, which is like making a ripple in a pond travel perfectly backwards to its source. The problem was that existing methods required changing a material's properties at almost impossible speeds, faster than a single oscillation of a light wave. This paper proposes a groundbreaking solution called a perfect time domain lens. Researchers theorized what would happen if they used a special metamaterial whose properties could be changed over time. The key ingredient is a negative index material, a bizarre, engineered substance that bends light in the opposite direction to normal materials like glass or water. As shown in these diagrams, the main idea is to take a medium and, while a light wave is passing through, flip its refractive index from positive to negative. When this happens, something incredible occurs. The normal forward-moving wave and the time-reversed backward-moving wave effectively switch roles. Instead of a weak, hard-to-create time-reversed wave, this new method produces a strong, dominant wave that is a perfect playback of the original. Crucially, this effect works even if the flip from positive to negative happens slowly, completely removing the need for impossibly fast switching. Here is where it gets really exciting. By controlling the properties of the material, they can make the time-reversed playback happen much slower than the original event. This graph shows an original pulse lasting just 100 femtoseconds being played back over a full picosecond, 10 times slower. It's like having an ultra-high-speed camera with a slow-motion playback function for light itself. They can also do the opposite, accelerating the playback to compress a long event into a very short one. They call it a perfect time lens because, unlike other methods, it doesn't just reverse the main part of the wave. It also reverses the evanescent waves, which carry the superfine, detailed information that is normally lost, allowing for theoretically perfect resolution. You might wonder how a slow change can capture such a fast event. The secret is that the ultrafast information is already stored within the wave as it travels through the material. The slow change in the material simply acts as a trigger to broadcast all that stored information backwards. So let's recap the important breakthroughs here. Researchers have designed a perfect time lens that uses a material switching from a positive to a negative refractive index. This creates a perfect, time-reversed copy of any light wave inside it, even the finest details. Most importantly, this playback can be dramatically slowed down, and the whole process works even if the material itself changes slowly. This could revolutionize how we study the universe on the fastest timescales. Imagine recording a chemical reaction or the flow of data inside a microchip in extreme slow motion, all using conventional, slower detectors. This time lens concept brings that possibility one step closer to reality, opening the door to technologies we are only just beginning to imagine.